Okay, in the last section, we learned one of the most important things about fractions. We learned that they're numbers that are written like division problems. We also know that fractions can be used to represent smaller parts of things. Now, since a fraction is just a division problem, if we wanted to, we could go ahead and do the division and get an answer. And that answer would be a regular number that's the value of the fraction. Let's look at this fraction, for example. 10/5. That's the same as the division problem, 10 divided by 5. Now we know that 10 divided by 5 is 2, so the value of this fraction is 2. So what's the deal? The value 2 doesn't seem like a smaller part of something. In fact, it seems like 2 of something. I mean, aren't fractions supposed to have a value smaller than 1? Here's the deal. If the top number of a fraction is bigger than the bottom number, then the value of the fraction will be greater than 1. But if the top number is smaller than the bottom number, then the value of the fraction will be smaller than 1. But if we divide a smaller number by a bigger number and get a value that's smaller than 1, then how are we going to write that down like a regular number? I mean, isn't 1 the smallest number we can write? Well, besides 0. Luckily, the answer is no. You see, we can write values that are smaller than 1 by using something called decimal numbers. To understand how decimal numbers work, let's first review how we write down regular numbers that don't involve fractions. We call those numbers whole numbers. We use whole numbers when we count things, and counting things is very important in math. The system that we count things with is based on the number 10. In fact, it's called base 10. And it uses what we call powers of 10 as the groups or building blocks that we count with. It's probably no surprise that our first building block is 1. And we can get bigger building blocks just by multiplying by 10. So our next building block is 1 times 10, or 10. And the one after that is 10 times 10, or 100. And the one after that is 100 times 10, which is 1,000. I could keep on multiplying by 10 to get bigger and bigger building blocks, but I think I'm going to stop at 1,000 for now. So what am I going to do with all these powers of 10? Well, like I said, they're the building blocks of our counting system. So I'm going to count with them. But before I do that, I should mention 2 more things that our number system needs besides these building blocks. And those 2 things are digits and number places. Digits are just the 10 different symbols we use for counting. You know, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Number places are like little imaginary boxes that can hold just 1 digit at a time. And they're used like counters, to count things. We use 1 number place for each of our building blocks to count how many of each of them we have. For example, let's say I have 2 hundreds. Well, then I just put a 2 in the number place that counts how many hundreds I have. And let's say I have 5 tens. Well, then I put a 5 in the number place that counts tens. And I also have 3 ones. So I put a 3 in the number place that counts ones. Each number place is named for the building block it counts. For example, this number place is called the ones place because it counts ones. This is the tens place because it counts tens. And the hundreds place counts hundreds. And so on. Of course, most of you aren't used to seeing numbers written like this, so let's rearrange our number places to make it look more like we're used to. There, now you can see that the 2 in the hundreds place, the 5 in the tens place, and the 3 in the ones place all combine to make 253. Oh, and most of the time we don't actually show the number places. They're invisible. There, that's better. Okay, so that's how we use our building blocks, number places, and digits to write any whole number we want to. But this video is about fractions, right? So how are we going to write fractions with this system? A lot of fractions have values smaller than 1, but right now our smallest building block is 1. It looks like we're going to need some smaller building blocks. You remember how we got our other base 10 building blocks. We started with 1 and kept multiplying by 10 to get bigger and bigger building blocks. Well, to get smaller building blocks, all we have to do is start with 1 and keep dividing by 10. Wait a minute, divide a smaller number like 1 by a bigger number like 10? Well, that sounds like a fraction to me. Exactly. If we do that, the building block we get will be a fraction, and its value will be 1 part out of 10, or 1/10. And we can use that to write values that are smaller than 1. A good way to see how this new building block fits in with the other ones is to look at a number line. Oh, look, a number line. And it goes from 0 to 10, and it shows our first 2 building blocks, 1 and 10. If we take 10 and divide it into 10 equal parts, each of those parts is equal to 1. And if we take 1 and divide it into 10 equal parts, then each of those parts is a 10th. Now our number line shows 3 building blocks, 10, 1, and a 10th. A 10th is a small number. But we can get even smaller building blocks if we keep dividing by 10. So let's take 1/10 and divide it into 10 equal parts. This even smaller fraction is called a hundredth, which is 1 out of 100. And since it's 1 over 100, it would take 100 of them to equal 1. We can see this by taking all 10 of our tenths and dividing each of them into 10 parts. Now if we count up all of those smaller parts, we'll find that there are 100 of them. We could keep on dividing with our number line to get smaller and smaller building blocks, but I'll show you an even easier way to find them. Let's list the building blocks we have so far. Notice that on this side of the 1, the first building block is 10. And on the other side of the 1, the first building block is 1 over 10. And back on this side, our next building block is 100, and on the other side, it's 1 over 100. Well then, if the next building block on this side is 1,000, what do you suppose the next building block on the other side will be? Yep, you guessed it, 1 over 1,000, or 1,000th. Of course, I could keep on going in either direction, getting powers of 10 that are bigger and bigger whole numbers, or smaller and smaller fractions, but I think these are enough for now. Alright, now that we have all these new smaller or fractional building blocks, it means that we can count smaller and smaller parts of things. But to do that, we're going to need a new number place for each of them. This will be called the tenths place because it counts tenths, and this will be the hundredths place because it counts hundredths, and this will be the thousandths place because it counts thousandths. To see how the new number places work, let's bring back our last example digits: 2 hundredths, 5 tens, and 3 ones. But this time, let's add 6 tenths by putting a 6 in the tenths place, and 4 hundredths by putting a 4 in the hundredths place. Now let's put our number places back like we're used to seeing them. Uh-oh, looks like there's a problem. This number looks like 25,364, but we only added tiny little fractions to our 253. It can't be that big. Here's our problem. We can't tell which number place is which because they all look the same. What we need is a kind of marker that will help us tell them apart. And that marker is called a decimal point. The decimal point is just a dot that we always put right here between the ones place and the tenths place. That way we always know that the ones place is on the left of the decimal point and the tenths place is on the right. There, that's better. Now our number reads 253.64. That's how you read the decimal point when you get to it. You just say point. So the decimal point is really just a separator between the number places that count whole numbers on this side from the number places that count fractions on this side. These amounts are greater than 1, and these amounts are smaller than 1. We call numbers that use a decimal point decimal numbers, or decimals for short. So that's how decimal numbers work, and they're important because we use them to convert a fraction from a division problem into a regular number. In the next section, we'll learn how to convert some special fractions into decimals. But before that, let's do a quick review. If we take a fraction and do the division, we'll get an answer. And that answer is called the value of the fraction. Our number system is called base 10. It uses powers of 10 as building blocks for counting, as well as 10 different digits. Number places are like counters that hold one digit at a time and help us count how many of each base 10 building block a number is made of. There are base 10 building blocks like 1, 10, 100, and 1,000 that help us make really big numbers. There are also very small base 10 building blocks, fractions that are smaller than 1, that help us make really small numbers. These building blocks have names like tenths, hundredths, and thousandths. The decimal point is a separator that goes between the number places that count values of 1 or greater from the number places that count values smaller than 1. To make sure you understand how decimals work and how they relate to fractions, be sure to do those exercises. Bet you didn't see that coming, did you?
Learn more at mathantics.com.